Air-Ocean was the unit on meteorology, and our very first lab was called Rain in a Bottle. Rain in a bottle, as it might sound, is about how the water cycle works. So the first thing we did was take a look at the critical concepts, noting that we'd already talked about the atmosphere and the layers of the atmosphere, and that we really should be focusing on the water cycle, about rain, water vapor, and the energy that might have to do with that. That was my first little hint. The next was to do some research using chapter 1 and 2, but specifically the chapter about energy and the water cycle. After that, we talked about the fact that the atmosphere, troposphere, ionosphere, oxygen, things that we might find in the layers had already been discussed, but that we might want to talk about things like condensation, precipitation, conduction, convection, words that we hadn't really used yet, but that we could see if we were to take a look at energy in the atmosphere, what is weather, and other homeworks that would provide clues as to what this lab was going to be about. We then introduced the question to rain in a bottle and noted that it's easy to get drinking water unless you live in a desert. So the question, can you find fresh water, can you get fresh water out of dirty water, is pretty simple, really easy to change. But we'll note that there's not many materials here. Basically a 2-liter water, some cups, and some optional ice and sunlight. So I introduced the idea that the Kalahari Desert, a place where I'd lived for several years, was very dry, and the people that lived there, the Basarwa, had lived there successfully for about 60,000 years. That they were able then to use their resources and live within nature. So how do you live within nature and when you need water? So the next thing was to talk a little bit about the water cycle. We'd actually collected. The actual activity for Rain in a Bottle is pretty straightforward. We're going to try to make fresh water out of some dirty water. There are 3 big ideas here. The first being that the water cycle involves evaporation, changing from a liquid to a gas, condensation, the changing of a gas back to a liquid, and precipitation, the falling of that liquid out of the sky. The other idea is the energy from the sun. Radiant energy traveling as rays or waves. Convection, the movement of materials because of differences in density, flow of materials. And conduction, which is the flow of energy through touch. The last big idea, obviously, is the changing of states of matter from solids to liquids to gases. So the first thing that we did was got the materials here, and we took some water, made it a little bit dirty. The one thing here that I didn't, and I don't have anymore, is my ice, so we'll just use these as a representation. The idea was to take the dirty water and somehow clean it out using just these materials. So what we sort of figured out was, if we put this together in this way, put the smaller clean cup on the water, and one of the hints that I had given was, remember, the name of this lab is Rain in a Bottle. It's thinking about the rain cycle. The second clue was, don't forget that the troposphere is warmer at the bottom and colder at the top. Warmer at the bottom, where our radiant energy might be, colder at the top, where the ice would be. And then the last hint that I gave was, imagine you're lost in a rubber raft in the middle of the ocean, and with all the dirty water around you, you still couldn't drink the ocean water, but you had enough to drink. So here we have the final setup under our radiant energy. So the radiant energy from the sun warmed, evaporated the water. It rose through convection, touched the colder surface. The energy moved from the radiant energy to the water, from the water into the air. The air eventually touched the colder ice surface, condensed, turned back into a liquid, ran down and dripped as precipitation into the cup, which allows you to have clean water out of dirty water. These are used all over the world as solar stills. They're used in desert areas, places where there's not a lot of fresh water. That's rain in a bottle. So the next thing we did after the activity was to sit down and say, oh, so what exactly happened here? We talked about the fact that this is a pretty typical water cycle diagram, and that the biggest problem is the fact that evaporation they have labeled up here above the clouds, when we know in fact evaporation first really needs to get going by the radiant energy of the sun. So we first need to have a little bit of radiation in there. And the radiant energy from the sun is able to warm up the liquid and change it into a gas. That gas then is drawn up by the warmer, less dense air into the upper atmosphere, and up in the upper atmosphere, as we said, it is cool. Down here it's a bit warmer because in the entire troposphere, it cools as you go up. So the gas molecules rise up with the warmer air, start to condense onto the particles of dust, and then either fall out because they become more dense, depending on the temperature, as either snow or hail or sleet or simply rain. That completes the last of our water cycle. So the water cycle that we're talking about is a little bit more complicated than simply the diagram that we might have looked at in the past. So the big ideas here are radiant energy through waves or rays. Convection is this movement of material based on differences in density or the flow of matter. And then conduction, that is the movement of energy through touch. So 3 movements of heat. The next part would then be the kinetic theory of matter, which we talked about, and which is a complicated name for saying solids are one state of matter, liquids and gases are another, and that as you add energy, you melt, you evaporate, and as you take energy away, you condense, you freeze. So in our case here, we're going to be talking about the radiant energy from the sun causing the gases to rise up and to conduct out their energy. So the last thing was to take all of our materials together and start to put them in the way that we use them. So the first thing we did was to take our top, and we wanted to make sure that it was upside down and inside our bottle. So we took that and we moved it. Well, we might as well put in the water there. Put the cup in. Then drop our top down inside. Get the ice and put it inside. And at that point, now we start the explanation. So I said the best way is to take and talk about the energy of the sun. So the first thing that we have here is the energy of the sun is called radiation. So radiation, razor waves traveling through the atmosphere to our water. That water then gets a bit warmed up right here on the transition between the liquid and the gas, and that's called evaporation. It's going to rise up because it's warmer through convection, and then it's going to eventually get all the way up here and touch this surface. The energy is going to conduct into the ice. So we'll take a little small one there. We'll shrink it down to show how it moves out of the bottle and into the ice. So now our energy's gone, and we can therefore change it back from a gas to a liquid. That is going to allow it to run down the edge and drop into the cup. Turn that around and give it a little shrink down there. So there we have our movement, and that we know is called precipitation. So in the end, we've got the radiant energy of the sun warming up the liquid. The gases change, the liquids change to a gas, rise up because it's warmer, and the cool air is going to drop down through convection. It's going to touch and lose its energy through conduction, and then the gases are going to be changed to a liquid. It'll run down the edge and drop in as rain, called precipitation. Conduction, convection, radiation, and evaporation, condensation, and precipitation. Rain in a bottle.